Okay, here's a fun one. What on earth does the seaweed growing on the ocean floor have to do with the ice cream sitting in your freezer? Well, the answer involves a pretty cool high-tech scanner, and it might just change how we guarantee the quality of, well, a whole lot of things.
So let's get right to the heart of it. How can a simple flash of light, something that happens in an instant, guarantee that our food, our cosmetics, and so much more are actually up to snuff? To figure that out, we've got to start at the source.
And believe it or not, the key to this whole high-tech solution is hiding in a place you might not expect, the absolutely massive, hidden economy of seaweed.
So, meet Capophycus alvarezi. This specific red seaweed is a total powerhouse ingredient. It's harvested in tropical waters and is absolutely crucial for a ton of different industries. And why is it so important? Because it is packed with something called carrageenan. Carrageenan is a hydrocolloid, which, is a super fancy way of saying it's an amazing thickening and stabilizing agent. It's that secret ingredient that gives so many products, from ice cream to cosmetics and even medicines, that perfectly smooth and stable texture you expect. You've probably used something with it in it today. But here's the catch. The quality of that all-important carrageenan really depends on the seaweed's water content. And the old-school ways of testing for it, well, they're just not great. They're slow, they take a lot of work, and get this, they're destructive. You actually have to destroy the sample just to test it. There just had to be a better way. This huge problem pushed researchers toward a pretty brilliant solution, one that uses the power of light itself.
The key here is a science called spectroscopy. Think of it like this. Every single material in the world interacts with light in its own unique way, which creates a kind of light signature. So if you can learn how to read that signature, you can understand all sorts of things about a material, like its water content, without ever having to touch or destroy it.
So that led to a really clear mission. They needed to build a portable, non-destructive tool, something a farmer could literally take out to the coast, shine it on a fresh batch of seaweed, and get an instant quality reading right then and there. So how did they pull it off? I mean, this wasn't some off-the-shelf gadget you can just buy online. They had to invent a brand new device pretty much from scratch.
The blueprint for their device, which they nicknamed SeaSpec, was actually beautifully simple. It has an input, that's the high-tech spectral sensor that reads the light. Then there's a process, that's handled by a little microcontroller that acts as the brains of the operation. And finally, an output, a display that just shows you the results in real time.
And here it is, the finished product. You can really see how it went from a technical drawing to a fully functional, portable instrument. You've got the display unit, and then that separate black chamber that holds the sensor in the sample, which is specially designed to block out any stray light from outside. Okay, but building the device? That was only half the battle. Now came the really hard part. They had to teach it how to read and actually understand what it was seeing in the seaweed. To do this, they set up this super meticulous experiment. They took fresh seaweed samples and put them in an oven at a constant 40 degrees Celsius. Then, every 15 minutes, like clockwork, they'd take the samples out, weigh them to see how much water had evaporated, and then pop them into the SeaSpec device for a scan. Now, the whole point of this painstaking process was to build a massive reference library. By scanning the seaweed over and over again as it dried, they were capturing a unique light fingerprint for every possible moisture level. This giant data set was the absolute key to training their device to make smart, accurate predictions. Okay, let's get into the results, because this is where they found out which kind of light was the true champion for this job. Take a look at this graph. See that red line? That's the light signature of seaweed when it's totally waterlocked. Now look at the blue line, way down at the bottom. That's when it's down to just about 18% water content. You can see it clear as day. As the water disappears, the way the seaweed reflects light changes a lot. This was it. It confirmed their whole idea. The light signature is directly tied to moisture. So the sensor they used can actually see a huge range of light, everything from the visible colors our own eyes see, all the way to the near-infrared spectrum. So that brought up the next big question. Which part of that spectrum is actually better at doing this job? To figure it out, they put them head-to-head, analyzing the data from both the visible and the infrared spectrums. And wow, just look at these results. That goodness of fit score, the R-squared value, that basically tells us how well the light signature matches up with the actual water content. A score of 1 is perfect. And as you can see, visible light score of 0.79 is way better than infrared's 0.61. And that difference gets even starker when you look at the raw prediction accuracy. The results were totally decisive. Visible light wasn't just a little better, it was the clear winner, hitting nearly 81% accuracy. Just think about that for a second. That's a 4 out of 5 certainty of the seaweed's quality, delivered from a single flash of light. The infrared spectrum, it just couldn't keep up. So an 81% accuracy rate is great for a research paper. But what does that actually mean out in the real world? Well, for the seaweed farmers and all the industries that depend on them, the impact is huge. Seriously, this technology is a total game changer. It means farmers can check quality instantly, right there on the coast, instead of waiting days or weeks for slow lab results. That leads to less waste, lower costs, and a much more stable and reliable supply chain for all those products we use every day. It's a powerful new tool in their toolkit, but the implications here go so much further than just seaweed. This whole study is what you'd call a proof of concept. It shows that these kinds of portable, non-destructive light scanners are an incredibly powerful tool. I mean, just imagine similar devices for agriculture, for managing fisheries, or even for monitoring the health of our oceans in real time. And that really leaves us with a final thought to chew on. If a simple flash of light can tell us something so incredibly complex about a humble piece of seaweed, what other secrets that are hidden all around us in the natural world are we on the verge of unlocking? What else will we be able to finally see and understand just by learning how to read the light?